Hey guys, we're going to look at lesson 2.4. 2.4 is a continuation of 2.3. We're looking at domain and range still, but we're looking at it from a real world context. So that means we kind of have to look at the information given in a word problem. And we're going to determine whether or not it's discrete or continuous. In other words, does it have only specific values, or is it a more continuous non-set thing? And those set things would be my x values, my independent variables. Can they be a whole integer? Do they have to be a whole number? Can they be negative, right? Or can they be rational numbers, including fractions and decimals? And then we're going to look at how to write that again, just in a real world context, looking at it from a word problem. So let's look at a discrete situation first. So we know it's discrete already, and so every time you see a problem that's similar to this one, it's going to be a discrete problem, or it's a discrete situation. So the situation is: the total cost in dollars to buy uniforms for the players on a volleyball team can be found using the function where U is the number of uniforms bought. There are at least 8 players, but not more than 12 players on the volleyball team. Okay, I just realized the function was missing, so I'm going to start over the situation. So the total cost in dollars to buy uniforms for the players on a volleyball team can be found using the function, it's now written above, C equals 34.95 U plus 625, where U is the total number of uniforms bought. There are at least 8 players, but not more than 12 players on the volleyball team. Find the reasonable domain and range for the situation. So in this situation, it tells us that U is the number of uniforms bought, and we're having somewhere between 8 and 12 players. Now, we are assuming that each player only needs one jersey, so we're going to need anywhere from 8 to 12 jerseys or uniforms bought. C is the total cost. So I'm going to go ahead and make a note of that here. The total cost, C, so C equals 34.95 U plus 625, tells us that each uniform is $34.95 plus some kind of base fee of $6.25. Okay, so it tells us to find a reasonable domain and range for the situation. So let's break it apart. Okay, the first thing I'm going to do is I'm just going to rewrite my equation, since it gives us the equation, okay, because that can give us some valuable information. So C equals 34.95 U plus $6.25. Okay, so $34.95 per uniform plus $6.25 extra. Okay, and remember, U stands for the number of uniforms, and that is determined by how many players we have. Okay, and since I know that, I can identify what my possible value for U is. All right, go back to red. Right, since I know that there are somewhere from 8 to 12, it says at least 8, so you have to have 8, and then no more than 12, so you can have anywhere from 8 to 12. That's telling me that my U value is either going to be 8, 9, 10, 11, or 12. Those are my possible values for U, right? Because of that, and that's since those are the only numbers that I can have for you, that's my domain. Okay, well, let's think about this. How did I know it's my domain and not my range? Well, remember, domain is my x values, my independent variable, right? It's my Dixie, right? Where D is the domain. For my independent and my x values and my input, okay, I'm inputting the number of uniforms that I need, and I'm getting out the total cost, right? The amount of uniforms I'm buying determines the cost. So my independent variable is the number of uniforms I buy. The cost has to be dependent on how many I buy. not the other way around. Okay, so that's where I just sit back and I kind of read the problem and say, okay, what causes the other thing? What, and what, again, I can look at too, what am I putting in, right? And it kind of gives you already, since it's asking us to solve for C, we should go ahead and just kind of have in our memory, in our mind, thinking, okay, that's probably my dependent variable, which is going to end up being my range. Just remember that's Roy D, right? Range, output, Y values, and dependent variable. Okay, so that's kind of how I identified. And again, since my U was kind of part of the problem, I could establish that was my independent variable. Okay, so a reasonable domain, and we write it in set notation, just as with any kind of discrete situation, we write it in not set notation, in brackets notation, right, where I have little curly brackets, and I know that those are my only values. 8, 9, 10, 11, 12 are my only values for my domain, and so that is going to be my answer. Can I get half a jersey? Can I have half a person? No. So I can't have 8.5 as my as one of my domain values. Okay, I can't have 8.2. I can't have 10 3/4. I can only have whole numbers, and it tells me I can only have whole numbers between 8 and 12. So this is, again, one of those things where I have to look at, okay, this is a discrete situation because I can only have certain X values. I can only have certain values. It's not going to be a continuous line where it's everything in between my whole numbers. Okay, I can only have 8, 9, 10, or 11 people on the team. Therefore, I can only have 8, 9, 10, or 11 or 12 jerseys. Okay, well, let's look at what then my range could possibly be. Okay, so since I know that my possibilities for my U, I can go ahead and plug that in to the formula given, the function given, to see what my possible values for C, or the total cost, are. So if I were to rewrite my equation, instead of plugging in U, I'm actually going to just put brackets to show which U values I'm putting in. 8, 9, 10, 11, or 12. If I were to plug those in for U, then I can find my answer. So to find my range, all I have to do is plug in the possible U values into my equation and then just simplify them or evaluate the function. Okay, so in order to find my reasonable range of all of the values, or the total costs that I could, I'm just going to plug in 8 for U, and I'm going to do $34.95 times 8 jerseys plus $6.25. And then I'm going to do the same thing. I'm going to do $34.95 times 9 uniforms plus $6.25. And then multiply, follow the same pattern for 10, 11, and 12 to find all of the different ranges. Okay, and just as with the domain, there are certain specific costs, total costs that I can have. Since I can only have certain amount of uniforms, there is a certain amount of costs as well. So here are my lists for my reasonable range after I have evaluated all of the values for U. If I only get 8 uniforms, then my total cost is going to be $285.85. If I buy 9 uniforms, my total cost is going to be $320.80. And then so on and so forth for 10, 11, and 12. Okay, again, I write those in those curly brackets, and those are my reasonable domain and range. Now let's look at a continuous situation. And remember, this is more where we have a connected line, and not just a set of points on a graph, right? It looks more something like that, right? Or it could just be a line, could be something like that, okay, with arrows, or maybe it's an endpoint, okay, it's something like that. So let's look at the situation. A pot of water at a temperature of 60 degrees Fahrenheit is placed on a hot burner. The water temperature increases at a rate of 25 degrees per minute for 3 minutes. Make a table of the values. Okay, so what I'm given so far, and let's look at some key things in this, is that I have a pot of water that's at 60 degrees and it's placed on a hot burner. And then my water temperature is going to increase. That means it's going to go up at a rate of 25 degrees per minute, but then only for 3 minutes. It says make a table. So let's make a table over here. Right? Let's use X and Y. Okay, well, let's look at what is causing the other thing. Okay, the temperature, right, and the amount of minutes, okay, and it says it's going to be, the temperature is going to be increasing at a rate of 25 degrees per minute. Okay, the way that it says it's a rate of 25 per minute means it depends on the minutes. The temperature of the water is going to depend on how long it is heating up for, right? Because we're currently and actively heating up the water. So my number of minutes is going to be my X values, and my degrees is going to be my X values. I'm just going to put degrees in Fahrenheit. All right, so let's see. At the start of it, what is my starting temperature before I've even heated it up? Well, it tells us it's 60, right? We have a pot of water, it's at 60 degrees. And then it's heated up for 3 minutes. So my X values are 1, 2, and 3. Right? It's increasing at a rate of 25 degrees. So that means after the first minute, my temperature should be at 85 degrees. After my second minute, I've added 25 more degrees. My temperature should be 110. And then after after 1 more minute, it's gone up 25 more degrees. And I have a stopping temperature of 135 degrees. Okay, but let's look now, because my number of minutes, time is constantly passing, right? So am I going to have a temperature at 30 seconds? Yeah, I'm going to have halfway between 0 and 1 minute. My temperature is still going to be increasing to get to that 85. It doesn't just jump, right? Time is a continuous thing. It goes on. And so that's why my temperature is going to be increasing at a steady rate. Okay, it would look something like where it would start at, well, maybe I don't draw a big graph. Okay, if I say this is 0 minutes, 1, 2, 3, 1, 2, 3. Okay, and I say here, okay, maybe if you'll let me mark on it. There is at 60. Okay, then at 1 minute, it's going to be going up, and then at 2 minutes, it's going up more, and then at 3 minutes, it's going up even more, right? And I end up with a line going through those points. Okay, that is a rough idea. So see here that even though I'm going from 1, 2, and 3 minutes, and I have specific temperatures that I know it's at each minute mark, my temperature is still increasing at the same rate to get us there each time. So my reasonable domain would be written in inequality notation, right, where we use our less than or equal to or less than symbols. So here we have to pick the inequality symbol, and we have to pick the variable x or y. So my reasonable domain, we're going to be dealing with the x values. My smallest x value. What's my smallest amount of minutes? It's 0. So I know it's going to be 0. Now, am I including 0 in my information? Can I have 0 minutes? Yes, absolutely. So it's going to be 0 less than or equal to x. So x is greater than or equal to 0, but less than or equal to 3. I only want to know the temperatures between 0 and 3, including them though, because I go from 0 minutes to my 3rd minute. Now let's look at my range. All right, remember we always go from lowest to highest there. So my lowest temperature that I have is 60 degrees. And it is included, right? I have a temperature of 60 degrees. So it's going to be less than or equal to. So y is greater than or equal to 60 and less than or equal to my highest temperature, which is 135. Now, I know if we kept heating the water, my water temperature would go up. But since I'm only looking at this specific time frame from 0 to 3 minutes, my temperature, the highest it ever gets in 3 minutes, is 135 degrees. So that's my range for that set. Okay? So my graph, if I were to draw it, would actually stop right there. I would have nothing on that other side because I'd be stopping at 3 minutes. Okay? Let me know if you have any questions. Let your teacher know if you have any questions about looking at real world situations.